All right, guys, I'm just going to share how we did one project. I mean, modularize yung work and then using CocoaPods. And since CocoaPods has private, private pods, and we also have the public one, which is GitHub, right? And I'm pretty sure everyone's using CocoaPods here. Yeah, okay. So it's also the reason earlier I asked about yung sa Swift, yung dependency manager. Yung package manager, I think it's called package manager. Right? Package manager ba yun? Okay, so of course, the first thing is, you have to know what you are trying to, what kind of feature. So in my demonstration, it's a very, very simple application. And to get started, of course, you need to have CocoaPods installed on your Mac. And I already have one. I will not go through that process. But in this case, I'll just, this is just a high-level demonstration. Later will be, am I correct? The in-depth? Okay, so let me just grab, let me open the pod project. Okay. So on this one, so I have this project, and then at the bottom you could see yung pods. This is this is what you see normally when you do a pod install. This entire project was created via the terminal. Let's say, let me open yung terminal. So what you just need to do is you just is the resolution right? Yeah, okay. You just pod lib create, and then the name of your something like that, and then it will yeah, of course, it will clone the template from GitHub, and then it will ask you several questions. Let me just do it again because I need to do it on the right directory. So again, it's doing its job, cloning the pod template, and then just answer some questions. Would you like to include the demo? Yes, you would. Yeah, you would answer yes. For now, none. No testing kit. And view base, no at the moment. Class prefix, let's say mypod, so MYP. Okay, so there you go. So it's done, and then automatically you would see this, and it looks like it is very similar to what I have earlier. So you could easily get started with this one, and then you could already start working on your pod. So the area where you will be working on is on this one. You would be adding your classes here. You could add additional, let's say, directories for other content, such as your zip files, your images, or whatever you want to add. And then if we look at, I don't know, if we look at the directory, yeah, let me open yung the directory and how this thing looks like. Yeah, and let me go back to the root directory. So this is the folder where the pod has been created, and this is exactly the place where your code are, the ones that you're going to share, and then your example. This is very typical. I guess nakikita nyo to when you export or clone a pod with an example. You would see this example folder with the pod. And but you have another option. You can just straight away create an Xcode project and then organize your classes, your code into another folder. You don't need the terminal. The template is just a way for you to get started quickly. Pero you can also do it, but just by simply creating an Xcode project and then organize your code into one directory, and then later on the pod spec, you declare which classes you would want to share or you want to be included in the pod library. As easy as that. So the next thing that you need to remember is this guy, the pod spec. The pod spec tells the when installing the pod, it tells CocoaPods which repo to where you can get the code, and then what dependency. I guess you know some of it already, and then you're aware of these things. Just want to highlight some of it, like the source files. Normally, these are the, let's say it's since my demonstration is Objective-C, so it would be the header files and the implementation files, and then resources if you have, and then which are the public header, and so on and so on. And also if you have dependency like AF networking, let's say in your code, in your pod, it uses AF networking, for instance, or another pod that you had created, you can declare it here. So by the time the user would type pod install, it will pull that resource or that library. Okay, let me go back to the one that I created earlier. So this is a very simple, let me just maximize this. Simple pod, let me go through. So I have this sample client pod. Let's pretend this is a client for Facebook or a client, it's an SDK more or less. And then I created a person class here. And there you go. And then I also have a header, which is the sample header. It's an umbrella header. You guys know what an umbrella header already, right? Umbrella header, it's well, it's Objective-C, of course. This is a Swift group. So, but then the term is about where you put all the headers in one place, so at least you only need to access one header. Para you could automatically, it already has imported the rest of it for you. So basically, umbrella header. Then I created a view controller. The reason I included this on the demo, because of course, if you wanna, let's say, add or create a pod for one feature that includes user interface, might as well have it here, and then I'll also demonstrate how it's being used. Okay, so I'll go back to this one. I'll open the project that uses the pod. Okay, so on this project, it's a simple view project wherein kumbaga, you have this view and then you click next. It opens the view controller that is coming from the pod. Okay. So initially, this is the, let's say this is the main application. And then the sample client is a feature done by your colleague or someone remote. So you needed, let's say you need him to do the login, you need him to do the just UI, basically. You know, separation of the entire user interface, and then it's done on a different pod, and then you just pull it into the main application. You could do that if you want. It's a total separation of the user interface. So if I'm going to run this, hey, yeah, Trick Pirata. Yeah, you use, yeah, there's the pizza. All right. Oh, did I run it? Yeah, it's still running. There you go. Okay, so if I click next, okay, okay, I have a breakpoint. There you go. Let me close that. Yeah, and let me do it again. So this view controller is from the main application, and then the next view controller is from the pod. Okay, how was I able to get the view controller into this? Of course, the first thing is of course, I declared this sample client pod, and then I did the pod install, right? Typically, we normally, it's challenging at times to get or include or access the view controller, especially the SIB, from the pod into your application, into the main application. In order for you to locate the view controller is to locate the bundle where it is, the bundle or folder where it belongs. So I just created a helper method to locate it. So I did it by locating which bundle by just using NS bundle for class for this view controller. And then, of course, through that, I was able to, create an instance of the special view controller and then return it. Ayun, if you'd notice here on the view controller on the IB action where the button was tapped, I just called this one and I returned an instance. I already have the view controller and then I presented it. So as easy as that, you now have a feature working that is based on a certain pod on a different repository. And then anyone could work on that, check out, and update it. So let me go through the steps again. First, you create your project. And second is you make some changes on, or you create your pod spec. You declare, the important things there is to declare what version and some other meta information such as name, summary, the source, which repository it is. I mean, where you pushed the code, and then also tell CocoaPods which source files you want the user to be able to have access to, which resources. That's for the SIB in my example, and what are the public headers, and then okay, I think I know what I need to do. Oops. Okay, works. All right, so most of these information are on CocoaPods on their website, so it's easy for you to like, you know, get familiar with it. But these are the things that you need to know. The other thing that is important is the tag of your repo. So let me show you what I did. So as you could see, this is a view of the repository and the history. And then I'm currently, I tagged it as 0.10. So whenever I will do a pod install, it will locate this tag 0.10. Pero it will also depend on how you will declare it on your pod file. For instance, in this case, I didn't indicate anything, what version or tag, but I could, like 0.10, right? But you could also directly access the development branch, access the master branch, point to a specific commit. So it's up to you. If it's private, it's internal, so you just do that. The other important thing is the pod spec directory. This one is we don't do this normally. Show in Finder. This is the other thing that's important. You have to create. Otherwise, your pod is public. You can just upload it on the CocoaPods repository kung public yung library ninyo. But if it's within the company, so you create your pod repository and then you create your pod specs repository. You structure your pod specs repository like this. The name of your pod, second, the tag or the version, and then again, the pod spec. This one is different from what you see here. Oh, I'm sorry. Let me open the pod. Yeah, it's a different copy. This one is it's used by when you are accessing the pod in the same computer, not on a remote repository. Yeah, no. Okay, I just used the directory. They're in the same. I think they're in the same directory, so almost in the same folder. So ganyan lang through a path. That's why you need the pod spec. It also still requires this one, but when you want to access it remotely, you need to have the pod spec on a remote Git repo using this. Following this structure. So if you have 0.10 or 0 or version 1.100, so another folder will look like this. Oops. Copy. Oh, maybe it's the reason. It's the same version. 1.0.0.0. Okay. For instance, so make sure 1.0.0 exists on your pod repo. You have a tag 1.0.0. You change. So you also need to change this to, it should match. Yeah, 1.0.0. So whenever it will clone using a specific version, which is this one that you declared. All right. So basically, those are the things that you need. You need pod spec repo, you need your pod, and then later you could add it into your project. The other thing, when you're adding something, when you're adding a private pod in your project, is to make sure it's pointing to the repository, the PodSpec repo. Because when you pod install, it will complain because it could not locate the PodSpec of that pod. As you could see, typically you don't indicate source, right, when you pull something, because it already knows about this one, the second line. But when you have a private repo included, you need to declare this. Para it knows which pod spec to pull, and then through that pod spec, it knows which repo to pull. Basically, that's it. And then there you go. And then pod install. So I think I have everything here. All right. You have any questions? Yeah. Yeah. How would you be able to determine how to break up certain? First is reusability. Let's say networking type of pods. If you are not using something like if networking, you would want to set up your own. You could create a pod for that. In our case, let's say third-party SDKs, we have one pod for, let's say, for third-party SDKs such as the social networks. So we have Facebook, we have YouTube in one pod. So you just access which one, and then you already have the authentication web UI, blah, blah. So it's more of, thinking about, is it going to be reusable? So I can separate it into another pod. Is it something I can use on another project? I'll separate it. The other thing is it something unique? Maybe it's not reusable, but then is it something unique that could be encapsulated into one, because it's different from the rest of the applications. And it will also depend on your team structure. You have some UI, perhaps if you have a UI guys, then might as well give the UI guys their own place, or you have a non-user interface guys, so separate. This kind of approach will ensure avoid spaghetti code, avoid strong coupling. So it will decouple, actually. It will decouple the code. So then you will have the central application, which is the main app where it consumes it. Again, it's really the deciding which to separate, deciding which is going to be a pod. It's at when you're starting, it would be experimental. You would try and later on decide it's not. I don't think it's this. It has to be done this way. So, and then experience will tell you. And then when you move forward, you already have established all the pods that are reusable. You always use over and over again over time. Utility class, or right? You normally would say, I know, I remember I already done this, converting or formatting date into a string to a specific format. You would try to go back to a previous project and then copy the class. Why don't we just put it in one pod and then, they say enrich, just add whatever new features you think of related to that pod. And then later, you might have a README, and then so that newcomers would be able to distinguish one pod from the other by reading the README, what features it has, what methods, blah, blah. So yeah, it will make things cleaner, easier for the development life cycle. Yep, questions? right, there we go.
So,
Yeah.
if you have a big project, right now we have a big project. What we do is we have utilities that serve the helper function serving, for example, formatting. Right now, I can imagine if we transition to using fonts, we would have like just the utility scope going to be more than. So how would that affect the compilation?
I haven't used Swift for a long time. Only for when maintaining another application. So it depends, but because normally when you, well, what I know with Xcode 9, when something has been compiled previously and then there's no change, it will not recompile. If I'm correct, I don't know. If I'm wrong, I don't know. So, but then, yeah, you know, once it's on a separate target and then it has been previously compiled, I think it will be less work, I suppose. But yeah, the other reason why we haven't moved with Swift after the first Swift project that we had is the compilation. It took a while, right, compared to an Objective-C project. But now I don't know. Probably in Xcode 9 it will be much faster. And then if you have this kind of structure, of course, it will help on that aspect. But if it was a binary, I think it will be much faster. Yeah, in the project that we did, we also had a library which is a precompiled library that was written in C++, I think. So yeah, so the binary will just be loaded and then it already has headers, and so it will not be precompiled. But on frameworks, because yeah, anyway, it's Swift. It's supposed to use frameworks, so it would be a different story. So it depends on the compiler, I guess. Question pa po?
How do you let your team know kapag mayroong updates sa ibang parts na ginagawa ng master? Someone needs to work on the other part and someone's working on another part. Paano na-update pinakabilis na project?
It's a very good question. We had that issue wherein you check out. Tapos, of course, when you check out, your pod doesn't get updated, right? The one that when you pod install, you still have the pods in cache or in that same directory. The thing that changes is the main project alone. That is. Oh, again, let me just go back a bit. The way we do it is we exclude the pod directory from the repository. I have the main application that uses a certain pod. When I commit or push, we do not include the pod. We declare that in the git ignore. So so when you pull, let's say there are changes. When you pull, the pod doesn't get affected. When you run, it's okay. But if there are updates that is dependent on the pod, a newer version of the pod that you are not aware of course, it will break. But another safeguard is to do not add the pod lock. Is it called pod lock? Pod file lock. Ba yan? Yeah, I forgot. Yeah, pod file lock. You commit it. With the main application. Why? When you do a pod install, when you do a build, when you run your application, it will return an error because it determines that because the other guy, let's say the other guy updated his pod already. The pod file lock will get updated. It knows, what was the version that were installed. Pod installed. So it has a hash, it has the version number. So when you pull, you get an update from the repo. You get that copy too. It doesn't match now. It doesn't synchronize now with your pod directory. So when you do a run and then build or build a run, it will return an error. Now your pod or something, it's like not updated anymore. That's another way of you getting informed. You have an outdated pod, but of course the pod file, it is also a part of the repo. No, but let's say the main application wasn't updated. It's just that a newer pod has been published by your colleague or someone that you don't talk to regularly. Another way is to how you declare, let's say, how do you write your pod file here? So let's say, where's the, what's that, the, yeah, okay. It's this one and the greater sign. Ganito ba yan? Yan ba? Tama ba? Okay. All right. Is it the, yeah, okay. Squiggly or whatever line? What character is that? Ah, tilde. Okay. Yeah, tilde. That indicates na you pull anything newer or after on this. I suppose this is the last decimal, right? That's another way, Ren. So I guess there are many ways, but of course the best way is to open communication. But there are times we're too busy and we forget to communicate. So you can implement some safeguards. So when you run and build your application, it will return an error. So at least you could update your copy. Basically, that on our end, that's how we get notified that I have an older version. Yeah, question? This is good.